Let's begin with describing R. The R language is a statistics programming language developed specifically for data analysis, particularly among statisticians and mathematicians. It can also be described as a data visualization tool. It's open source and has many contributors. It has a huge community of users across industry, government, and academia that use R daily. There are R user groups in most major cities, and some of them are very active and very large. We encourage you to check out Meetup for local groups that meet regularly. Most important to the value of R is the huge repository of freely exchanged algorithms, techniques, scripts, adapters, techniques, training. CRAN, the Comprehensive R Archive Network, contains over 7,000 contributed packages, and all are designed to run with the R language. Traditionally, R is used to connect to data and query the data and use it for some analytics purpose. The data can be sourced from a range of different source types, including relational and big data stores. R is enjoying an unstoppable wave of popularity. In 2015, it moved from the number 9 most frequently used language to number 6. Only general-purpose languages are more frequently used than R. R is most widely used language for advanced data analytics, and used by over 2 million data scientists, statisticians, and analysts today. Data is the currency of modern business, from the cloud to on-premises and everything in between. Access to data anytime, anywhere from varied sources has become a requirement for successful planning and operation. Today, the R open source programming language enables organizations to move beyond reacting to data after the fact and begin predicting results and gathering proactive insights to help plan ahead. Today, advanced analytics using open source R are being performed only by highly trained and specialized data scientists, mathematicians, and analysts who can create and nurture these models. This means that many challenges and complexities remain in the marketplace. First, R on a single machine does not scale well. Second, there are many bottlenecks to performance. Third, there is a lack of commercial support, making it difficult to work with and also integrate R-driven solutions. And finally, many models never achieve business value because it's so difficult to deploy them to stable production environments. If you can imagine spending hundreds of thousands of dollars on a solution and having it never go into production, you can see why machine learning has been so niche up until this point. And so the situation is that SQL Server is one of the most widely used relational database products today, and R is the most widely used statistical and advanced analytical language. And there are complications from using R with SQL Server databases. It requires data extraction, bottlenecks in performance, data size limitations, it increases security risks, and it increases duplication cost. In response to the challenges posed by open source R, Microsoft developed R to scale to big data. Basically, an evolution is taking place. It parallelizes predictive analytics to increase data scale and speed. It analyzes data a block at a time and combines results. It escapes R's traditional memory limits. It's parallelized by distributing computation cores and sockets, and it minimizes data movement to accelerate analysis speeds. To date, R has been available only as an open source project, but now that's changed, and Microsoft is introducing a new value proposition. With R from Microsoft, you get peace of mind, efficiency, speed and scalability, and flexibility and agility. SQL Server 2016 R Services brings the perfect mix of fast querying and in-memory OLTP optimization from SQL Server 2016, as well as data exploration, predictive modeling, scoring, and visualization from the R Services family of products. It delivers unprecedented enterprise speed and performance for advanced analytics, thanks to near database analytics and parallel threading and processing. It also delivers scalability and choice not seen before from a stable commercial platform for advanced analytics. Its on-premises, cloud, and hybrid benefits, as well as its limits and large data sets, are unmatched. Finally, there is no additional cost because the offering is included in SQL Server 2016 Enterprise Edition. In addition, the ability to reuse existing R code and eliminate data movement across machines provides significant value. While open source R provides R scripts and CRAN packages, Microsoft R Server adds scalable parallel algorithms, no memory limits, high-query R development tools, web services deployment, and support and services, and it's integrated with SQL Server 2016. SQL Server 2016 continues to deliver a comprehensive, on-premises, enterprise-ready data platform that transforms complex data into actionable insights. SQL Server 2016 includes in-database advanced analytics, including R-based embedded analytics, big data extensions, T-SQL to R language integration, and direct deployment of predictive analytics to SQL Server. R users can load, transform, visualize, and learn from data assets in SQL Server. They can create or train predictive models. They can scale R analytics to big data using SQL Server R services. Connect to SQL Server 2016 from R tools for Visual Studio or third-party development environments including RStudio. And they can deploy and operationalize applications that use these predictions. SQL Server users can embed R to access predictive analytics from SQL Server. They can run R scripts and modeling algorithms from T-SQL scripts and within stored procedures. They can extend R capabilities to data engineers and application developers. And finally, they can easily embed predictions into BI and custom applications. Let's now consider also hybrid cloud solutions with SQL Server R services. There is the right once deploy anywhere, be it model in cloud, deploy on-prem, or model on-prem and deploy to the cloud, or model in Hadoop and deploy on SQL, or model on the desktop and deploy anywhere. With the cloud modeling and on-prem deployment, you could capture data in Data Lake and explore and transform in R. You can then deploy to SQL Server on-prem. This can involve SQL scoring and BI visualizations and exposing as web services. The advantages of this scenario include cloud economics and scale for big data, and SQL Server stability and privacy for deployment. Examples could include manufacturing optimization, point of sale, or anomaly fraud detection. With an on-prem modeling and cloud deployment scenario, model in SQL Server 2016, deploy models to Azure and expose services via Azure, with the advantages that you can score data sourced from the cloud, deploy globally via cloud services, and secure historic data locally. This could be used for cloud-connected Internet of Things or healthcare data. A typical predictive analytics process involves 3 steps. At step 1, to prepare involves assembling, cleansing, profiling, and transforming diverse data relevant to your subject. At step 2, the modeling will use statistical and machine learning algorithms to build classifiers and predictions. And then at step 3, to operationalize would be to apply predictions and visualizations to support business applications. It is important to understand that this can be achieved in real time and that SQL Server 2016 is the only platform that enables this capability. By example, credit card fraud detection demands real-time data analytics and a result set that provides a fast go or no-go decision, and this could be achieved with SQL Server R services. For complex, large queries across multiple databases with structured and unstructured data, you can leverage the power of in-memory analytics. The queries run in memory and provide a result set that can be sent to an API or visualization application. Let's now consider a DBA workload with R scripts. At step 1, install and enable SQL Server 2016 and R services. This requires the installation of SQL Server 2016 Enterprise, selecting the R services option, installing Microsoft R Open, and installing R services components. At step 2, to enable R scripts within T-SQL, this can be achieved first of all by configuring the SQL Server instance to enable external scripts, and then registering the R instance using register rxt command. At step 3, enabling data scientist workloads is achieved by configuring the firewall on the server for database clients, granting permission to read data, granting permission to run algorithms, installing Microsoft R on a client if not present, and optionally installing samples. In summary, SQL Server 2016 with R services combines data management with predictive analytics and machine learning. It provides R users with in-database analytics. It provides T-SQL users with access to R analytics. It enables users to analyze large data assets for more accurate models. It enables direct deployment of predictive apps into SQL Server 2016. And it enables scalable scenarios on-premises, in the cloud, or hybrid. Today, the strongest adoption is found in these 5 industries: retail and consumer products, financial services and insurance, government, manufacturing, and healthcare. Common to these 5 are tendencies to have invested heavily in capturing historic data, and new sources of data coming online at a rapid pace, and also significant opportunities to leverage prediction to improve business or organizational results. Here are some other game-changing analytics examples. And finally, here are some additional resources for you to continue your understanding of SQL Server R services.